All right, so taking a look at section 5.1, it is all about right triangle trig. Right triangle trig is where we're talking about right triangles, and we're using our trigonometric relationships. Theta is a measure of an acute angle in a right triangle, so theta has to be acute, primarily because if it's not acute, it's right in a right triangle. So we're talking about a right triangle. The sine is the leg that is opposite of theta divided by the hypotenuse of theta. Excuse me. The hypotenuse is always the side that's directly across from the right angle. And the side that's opposite of theta is the side that does not intersect that vertex at all. So it's the side that doesn't intersect the vertex at all. Cosine is the adjacent divided by the hypotenuse. The adjacent side is the one that connects the angle, connects that vertex to the right angle. And then our tangent is opposite divided by adjacent. So there are a couple of different mnemonics. Mnemonics are memory devices that people have come up with through the years to help us to remember the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. One of those mnemonics is SohCahToa, okay? And so that was like a chief SohCahToa, that referring to Native Americans or Indians, and that was his name, SohCahToa. When I write SohCahToa, I like to write it like sine is opposite over hypotenuse, so it's like that. Cosine is adjacent over hypotenuse, so I can see the relationship there. You could just as easily put like fraction bars here so that you can see that you're dividing there. One of the teachers at our school has taught the students that some old hippie caught another hippie tripping on acid, and that's the first I'd heard that one, and it has stuck with our students, so that's something that you might want to remember. Okay, so we're going to use SohCahToa, and we're going to use that to find missing angles and sides. So we're using triangle DEF, and we want to find the sine of angle E, the cosine of angle E, and the tangent of angle E. Well, the first thing we're going to do is we're going to circle angle E. So if we circle angle E, that's going to tell us that this is the angle we're talking about. So we're going to label all of our triangle parts in reference to E. So our hypotenuse is always the side that's across from the right angle. So this is our hypotenuse. The opposite side is the side that does not intersect the vertex E. So it doesn't have an E on it. So this would be our opposite side. And our adjacent side is the side that touches the angle and the right angle. So this would be our adjacent side. Okay, now as you noticed, we have the hypotenuse length is 41, the opposite's length is 40. We do not know the adjacent's length. So in order to find that, we need to do something to calculate it. Well, in order to calculate it, we do right triangle trig, which means we can do our Pythagorean theorem. So we have a squared plus b squared equals c squared. C is always your hypotenuse. I don't like to leave b as my variable because it looks like a 6 sometimes. So I'm just going to go ahead and solve this. So I know that my adjacent side is 9 because that's the square root of 81. All right, so now I just have to write my relationships, write my ratios. Sine, well, I remember some old hippie caught another hippie tripping on acid, or SohCahToa. So sine is opposite over hypotenuse. The side opposite is 40, the hypotenuse is 41, so this is 40 divided by 41. The cosine, that's our ca, or caught another hippie, which would be adjacent divided by hypotenuse. Adjacent is 9, our hypotenuse is 41. And then E is opposite over adjacent, so that would be 40 over 9. So again, that was opposite over adjacent, so that gives us 40 divided by 9. So then the next thing we're going to do is we're going to use the same triangle. So we know that this side is 9 because we're using the same triangle, but this time we're going to use angle F. So when we use angle F, our hypotenuse is still the side across from the right angle, so this is still our hypotenuse. The side that's opposite of our angle, though, this time is not the 40, it's the 9. And the adjacent is the one that connects F to the right angle. So our adjacent and our opposite switch when our angles switch. So our sine is opposite over adjacent this time, so it's going to be 9 over 41. And our cosine is going to be 40 over 41. So those just swapped. The sine of E was 40 over 41. The cosine of F is 40 over 41. And if you remember back, that's our complementary angles theorem. So the cosine of an angle is the sine of its complement. The sine of an angle is the cosine of its complement. That's one of our theorems that we had last chapter. Tangent is opposite over adjacent, so it's just going to be the reciprocal. So instead of 40 over 9, now it's 9 over 40. Okay? So our next thing we're going to do is we're going to actually apply this. So a 60-meter long string of a kite that you are flying is being pulled taut by the wind and makes an angle of 68 degrees with the ground. How far from the base of the kite would a person be if she's directly under the kite? So we're going to draw some pictures. So I've got my string here and the ground. It's pulled taut. Here's my kite. And right below the base of my kite, I have a little girl. And I want to know how far she is from the base. So when I do this, I've in essence created a right triangle. I know this angle is 68 because they tell me that in the problem, that it makes an angle of 68 degrees. And it tells me that the string of the kite is 60 meters long. So this is going to be 60 m. Now we want to know how far from the base of the kite would a person be. Well, from the base of the kite, okay, so she's being pulled taut by the wind and makes an angle of, right here is our base. So that's where the string is to here. So we're looking for this distance. That's a horizontal distance. So I'm going to use x. Is that the opposite or the adjacent side? Well, that's the adjacent side. Across from our right angle is our kite string, so that's our hypotenuse. So which of our hippies or which of our SohCahToas or which of our trig functions are we going to use here? Well, I have adjacent and hypotenuse, so that's cosine. So the cosine of 68 equals x divided by the hypotenuse. And we solve. So we have 60 times the cosine of 68, which equals x. And then you just type that in your calculator, make sure that you're in degree modes. And you should get 22.47. So that would mean that our distance from the base would be 22.5. So the person is 22.5 meters away. Okay, same thing for the next problem. This time we have a person looking up off the ground. So basically our person's standing here and they're looking up with their eyes at the top of their head. Their neck is craned. And we know that that person is 5 foot 6 inches. And they are looking up at a flagpole. Okay? So we want to know, hey, this person is looking up 30 degrees because they never travel anywhere without a protractor. And we know that when they walk to the pole, it's going to be 85 feet. So the question is, how tall is the flagpole? So we're looking for this side over here. So if we're looking for that side over there, is that the opposite, the hypotenuse, or the adjacent? Right, it's the opposite. So this is my opposite side of my angle. Across from the right angle is my hypotenuse. So that means this must be the adjacent. So, which trig function is it? Is it the sine? Is it the cosine? Or is it the tangent? Well, I'm looking for the opposite and I know the adjacent. So that's tangent. So the tangent of 30 degrees equals our opposite side divided by the adjacent. So we would just type in our calculator, 85 times the tangent of 30. And we got 49.1. Okay, and that's great, but what that does is that tells us the distance that's highlighted. Remember, this is the ground down here. So we know that this person was looking up from a height of 5 foot 6 inches. Well, since this is in feet, we need to make this feet. So 5 feet 6 inches is 5.5 feet because there's 12 inches in a foot. So we add 5.5 and we get 54.6 feet. And that would be how tall the flagpole is. Okay, and finally, the roof of a house is slanted at an angle of 28 degrees to the horizontal. The roof ends at a side of the house that's 22 feet above the ground. So we've got this house. Here's my horizontal. And we know that this is 28 degrees. And here's my house. Okay, and what we're going to do is the roof is 22 feet above the ground. So that means that this is 22 feet here. So what these people want to do is they're going to extend their house, want to make their house bigger, but they're going to do it by extending the roof. So they're extending this roof. Okay, so I don't know if they're making a garage-like thing, something to just store stuff in, or if they're going to build it all in or whatever, but they're going to extend the roof. So if we want to extend the roof, we need to figure out how long this side's going to be. So this angle, since this is the ground and that's the horizon, these right here are the same angle because they're corresponding angles. So this is 28 degrees. And we're looking for our hypotenuse because there's my right angle. This side is either opposite or adjacent. Well, since it doesn't touch the 28 degrees, it must be the opposite. So we have opposite and hypotenuse, which means it could be some old hippie caught another hippie tripping on acid. Since we are looking for the hypotenuse, we know the opposite. It's going to be the sine of 28 equals 22 divided by h. So just like before, we multiply both sides by h. And then we divide by the sine of 28. And you type that in your calculator. And I got 46.86. So I'm going to call it 46.9 feet. And that would be our hypotenuse. Okay, so that should cover the right triangle trig that you need.